thank you again for coming. I will facilitate you with the microphone because I need just it briefly, let's say. So the way in which we run those kind of panels here at Innovate is starting to, let's say, deep dive a little bit who are the people that we have on stage, starting to, let's say, explore the connection that brought them to Silicon Valley, to the job and the patient that they are nurturing. And in this case, I feel it's particularly valuable to start from Francesco Brianti, because again, it's ST for me. I'm Sicilian. ST has a very important base in Catania. Some of the sensors that everybody knows, like the MEMS, were basically designed there. And there are companies here in the United States, let's say large electric vehicle company or things like that, that actually have pieces that are built and invented in Sicily. That's, for me, is particularly interesting. Maybe I'm biased for that. But I'm very curious to know some other piece of the story after this long career that you had in ST, and which are the connections that you find valuable that brought you here in California.
Well, thank you, Leandro. Thank you, everybody, for being here tonight. This is a great opportunity for the Italian startups and for Italy in general. So, Catania. Yeah, Catania is one of, I would say, one of our 4 main sites for manufacturing for ST, and is actually one of the sites where the company is investing heavily for technology to enable power and batteries. Okay, that's one of the foundations for the robots that we are seeing in the next minutes. What has brought me here? I came here by chance. I came here because they offered me to come for research at Berkeley, and then they offered me to stay, and I decided, okay, that's a nice place. Weather is better than in Milan. I'm from Milan, sorry. There's no fog. Actually, yeah, there's no fog here compared to what we have in the northern Italy. And then I decided to stay, and I worked through different, businesses in the company. So from hard disk drives to ASICs, to specific technology for communication, and then I ended up from a designer to to marketing and business. So that was my career. And after 30 years, I think somebody at some point would take a picture of me and put in some museum and say that's the only guy in Silicon Valley that stayed for 30 years in the same company. But what is the good thing about the company and about ST, and I think about also what we need to do together as an industry, is that ST is very strong on what we call it cooperation and competition. So the strength, I think, of our company is that, and Silicon Valley is an example, is that we both compete with, of course, similar companies, but also we cooperate with them, because not single company can have all the ingredients to enable either the AI or the robotics and whatever is going to happen in the next years. So the company, we develop all kinds of products, from sensing to processing to security. And at the same time, we work together with our partners, but also with our competitors to enable this technology and bring technology forward. So that's, I think, is a short summary. Okay.
Thank you. This is also a good moment to cross the room without being noticed. Because I'm coming to you, Peter. So basically, we know that SRI is foundational for Silicon Valley. You had the opportunity to look at many different innovations. Hardware is a big part of them. And maybe you have this glimpse into the future, because we know that there are a lot of research going on, and probably putting together like a story in which your personal path and what you have seen in SRI could be, let's say, a good story for our audience.
Oh, see if I can do this, because it sort of works. I need the other hand, otherwise I can't really speak because I'm Italian, right? So my story is a very traditional sort of engineering background. That I ended up in a national lab, and as part of that role in the national lab, I was involved with technology transfer, and an opportunity came to come out to California and help a renowned institute like SRI. We're going to be 80 years old next year, to develop a much more robust technology transfer and commercialization program. So that's what I've been doing for almost 20 years. Not quite 30, but 20 years at the same company, doing mostly technology transfer, and of course, a big portion of that is spinning out, incubating startups. Yeah.
I would like immediately follow up because first of all, we heard you speak in Italian and I was not supposing that you were able to do it. And second, you were mentioning commercialization. And of course, this room is packed of inventors, people that love to bring together things and making invention, working on the desk. But it is not so often easy for them to also, I don't know, turn on the other brain and start to sell. If there is any kind of advice, this is again an opportunity to follow up for our startup in particular.
Sure, and my institution is 1,000 scientists, 60% PhDs, right? Most of them are not going to be founders, most of them are not going to be business people. But that's part of our role is to find, just like you're doing here, to find the right mentors, partners, entrepreneurs, to team with the technologists who are interested in seeing their technology, we say move from lab to market, right? And so that's part of my role is to ensure that there's a translation from the research mindset to the business mindset.
Stefano, you already have the microphone, so I will leverage yours. I hope that you know how to turn on from it. So,
Uno, due.
yeah, it's on, very on, yeah. Okay, we met recently, and I was very curious about the role that you have right now in EWS and this connection with the IoT. But I would like to start a little bit earlier because you went through like Apple and TNT, Bulb, Nokia. It's basically the history of communication and connected object here around. You are in the United States since 30 years. So where do you come from? How you landed those jobs? What are you doing here?
Thank you. First of all, thank you for having me here. So I'm from Milano. I was born in Milano in the 70s, but I grew up in Rieti, which is a small town next to Rome. It was famous because that's where Texas Instrument was back in the 70s, 80s, and I was very lucky. My father used to run TI back then, and I was able to pretty much grow up with technology. I mean, we had back then TI was also in the consumer products, so he would bring all kind of weird things, at home. For those that remember the first watch, the calculator. So that's where I think I got really the passion for technology, and I think it stayed in me. And then when I came here in the mid-90s, it was 95, 96. I was supposed to stay 6 months. So I graduated, I lived in Paris, and I did my master's, and I came here to finish it. And then 6 months turned into 30 years, right? So indeed, I've been here quite a bit. That was not the plan, but I think like a lot of us who are passionate about technology, we landed really in probably the perfect spot. So I was very fortunate, as you said, to work with many innovative companies. Apple, I worked at Palm, for those that remember Palm in the year 2000. I worked at Nokia in the good times when we were leaders when there was no iPhone, no Android. I've done a few startups, successful ones. One we got sold and Verizon acquired us, which was great. Few others didn't go as well, but that's the part of the story. But it is true. I mean, overall, I think if I look through all the companies that I worked, connectivity, connection has always been sort of that common thread. Could it be on phones, cell phones? It could have been when I worked for Juniper Networks for many years, driving the base stations and some of the work we were doing there. And now ultimately at Amazon, I run the IoT group. So pretty much if you have one of the top 10 car in the world, most likely it connects to AWS IoT. That's how we unlock your cars. That's how you can you get telemetry for your vehicles. Most likely home you have some sort of thermostat. You probably have some camera. Everything goes through the cloud, right? So I've been doing this for about 4.5 years, and certainly the edge AI, the physical AI, it's a big element for us, and I'm spending quite a bit of time myself in my organization focusing on that.
Grazie, Stefano. And this is exactly part of the framework for this panel, because we had this AI somewhere in the closet cloud that step by step was landing on screen and going to the IoT, and from there landing to robots. Talking about robots, we have Modar with us, and well, you are part of Silicon Valley Robotics, and you are in charge of Humanoid Summit. So you have seen probably in the recent months in particular like those humanoid robots racing. So try to connect a little bit of your story so we can know a little bit more about your background with what is going on right now.
Thanks for having me and for the invitation. I don't know if everybody has enough time. It's a long and twisted story, but 3-time founder. I got the Silicon Valley bug early on, or the startup entrepreneurship bug early on, mainly in computer vision, AI. Before AI was called AI, it was then machine learning and hand-tuned features, then deep learning, then got involved with automotive, computer vision, and sensor fusion. Did a lot of work with ST on the image sensor side and the AI chip side. Did all of that for the last 10 years. That's my last startup, and then started thinking about, just like in Hollywood, you know, they act and then they want to become a movie producer, etc. So I wanted to put together a fund. There was not much going on with robotics, with the exception of course, the traditional automation companies that were already established. And then I did follow a little bit of a trend on what was happening in China, read some reports, and so we said we're just going to put a fund together that's going to invest in humanoids, particularly, not just robotics, but humanoids as a niche. Except that there was no ecosystem, so we put together a fund a little over a year and a half ago, and so we're like, okay, where is the ecosystem? How are we going to have all the startups come to us? And so our first investment was into the Humanoid Summit. Instead of a startup, we had to create the ecosystem so we can get some sort of deal flow. It was a phenomenal success about a year ago, December 2024. Since it was a great success, we wanted to put together a follow-on to that, which was in London. So at the end of May, we hosted the European edition of the Humanoid Summit. Since then, we've made 4 investments, mainly in humanoids, 3 humanoids, 2 of which are going to come out of stealth next month at the Humanoid Summit, Silicon Valley in Mountain View. And so we're gearing up for, we're going to gear up for our next edition in Asia. So the next Humanoid Summit is going to be in Tokyo at the end of May 2026. So kind of seeing read the book cover to cover, put together the ecosystem almost with a small team, put it together from scratch. And, we kind of have a front row seat, I think, at what's happening in robotics in general, embodied AI or physical AI, and of course, what we call also autonomous intelligence, which is one of our thesis at the fund as a whole.
And probably it makes sense to restart exactly from you in your words for the second round of the question. That is, well, we call this place Silicon Valley, and Silicon is, of course, about hardware. But honestly, in the last 20, maybe also a little bit more years, was like software taking, let's say, the command of everything, becoming the center of any kind of a giant investment. In some way, it's still in this way, because AI, most of the funding is going on the software part, but software needs also a lot of power and a lot of water, a lot of infrastructure that are again hardware, and the only way that looks giving us the opportunity to create marginality and make those AI actually worth, it is hardware again. So my question is, like, this is Silicon Valley. We started from hardware. Hardware is back.
Definitely. So AI is making hardware back or come back. For the longest time, robotics has been a category, but it was almost soulless. It was mostly automation, advanced automation, some sort of whatever, fancy word automation. And for the most part, it was in factory floors and warehouses and whatnot. AI has been around only for, 3 years now, coming on 3 years. It's been phenomenal what it's done. The advantage for robotics is that AI for the last 2 years or so has been living in cloud, on a cloud. And so for the first time, for the last year and a half or so, we see these new models making phenomenal progress into physical AI and hardware. And so right now, it's really just a manifestation of AI into the physical world that we live in 3 dimensions. I'm incredibly excited, and so I think it's transformational to the tunes of what electricity and train and rails and all of these things have done, and mobile, etc. Every single industry will be touched by physical AI, in particular, not just AI as a software.
Yeah, and basically I agree with you, but I feel that we need to have like a reality check, and I feel that who is working on basically the component that empower all those potential device and robot, and who is connected those devices with the cloud, bringing AI end-to-end in any part of the network, basically are those that might confirm is the world is reacting in this direction. I would like to start with Francesco. Can you share, please, the microphone? And see, how is going from the semiconductor standing point? Are we building like a new generation of Silicon Hardware Valley?
I think we do. What is happening today is Michael, sorry, I didn't remember your name, Madame, was saying, we are seeing basically the need to deploy AI and machine learning into the real world. To do that, you need three things, basically. You need to be able to sense, you need to be able to process, and you need to be able to act in a secure way, okay? So those four things is what is driving the silicon revolution from the bottom in our companies and in all the companies doing semiconductor. What we see from our point of view is that each of these four things that I mentioned, they require specific development, but also they require specific technology and process technology. So it's not just the 2 nanometer node that everybody's talking about from TSMC, but you also need sensing for MEMS, okay? That is a different technology. You need silicon carbide for efficient power conversion, and you need secure elements to make sure that something breaks in a robot, somebody goes there and replaces the parts, and it's not a bad part or somebody can hack. So for sure, there is a very, very strong drive to change the way that we develop the products, but also the way that we customize the technology to make you efficient use of the software, okay?
Thank you. Stefano? I'm sure that in AWS you have also some number that maybe you, I don't know, want to disclose or share about how many objects are on AWS, or let's say what you see.
No, I mean, not a specific number that we disclose, but yeah, I mean, look, there are billions of devices connected.
You say billions?
Billions, yes, billions. But I think going back to your question about the Silicon Valley, I do believe that we have come full circle, right? I mean, in the 60s, 70s, it was Intel. That's what this valley was. And if you think about it today, we have a $5 trillion company that is based here, and it's a silicon company, right? At the end of the day, we have really come back, and I wouldn't want to repeat what my colleagues here said, but AI has certainly impacted quite a bit. And I think that the need of the hardware specific for running, and I think one of the topics that we'll discuss is the cloud versus the edge and that hybrid environment, be able to have that compute power at the edge to enable some of the things that we described is critical. And so yeah, I do believe that we are coming back to what the Silicon Valley was, but I would even say it's not just coming back to the physical. I think it's integrated. It's the hardware, it's the software. We're really seeing sort of the full integration back in. I think the robots are the perfect example of that integration.
Well, everything great that was coming from Silicon Valley was built on the top of hardware and software together. This was like the legendary part of Silicon Valley. Some of this was, of course, built at SRI. So again, you were in a very special place to observe and maybe also to act, to push some direction. You have 1,000 researchers there. I'm sure that they are forecasting part of the future and maybe setting also some direction. I'm particularly interested to understand, let me say, what is the intelligence of the system, in the sense that we have the cloud, and initially the cloud was like taking all the intelligence and delivering just a piece of intelligence by stream or giving answer to specific queries. But later we understood that working on the edge is particularly interesting and also save some money in this sense. So again, 1,000 researchers, what you see?
How much time do we have? Right, so I want to sort of take maybe a step back, first of all, sort of big picture robotics and the conversation around physical things. I think our definition of robotics needs to expand, right? So I can recall the days when there was the DARPA Robotics Challenge, and we had dozens of humanoids all failing, right? That was 10 years ago. And today we're seeing humanoids sort of cross that barrier, but that's not the only kinds of robots, right? And one of the things that AI will enable is that pretty much everything we interact with in the physical world is going to be a robot, right? So whether it's the Waymo that we took here, or it's the surgical system, by the way, the most valuable robotics company in the world is Intuitive Surgical, right? So we have to really think about how to expand that definition of robotics and how do things like AI enable that. One of the ways AI enables that is that many of these physical systems wouldn't even be able to operate if they didn't have, so the traditional hardware and software required very capable hardware that was very well defined. I think what we're seeing, one of the trends is really pushing the envelope in hardware, even in areas like quantum, where it wouldn't even be able to operate if you didn't have some form of AI to manage that. So that's really what, if you're looking sort of in the future, it's where is that AI going to touch those physical things and enable things that traditional software or traditional approaches didn't have. And that's in biology, that's in manufacturing, that's in chemistry, that's in all aspects of research. There's almost nowhere where it doesn't touch. And those are the kinds of things that we're seeing, right? More and more embedded capability and intelligence in everything.
Thank you. We will have the pitch later, and there are companies in this group that probably, they have some piece of the puzzle of what will be the future of, for example, interaction with those AIs that are not just screen, are not just like the classic idea of robot. So, of course, they are not giant. Of course, they are not yet completely ready. But take a look to them, because I see the glimpse of something that is going to be interesting in the really near future. The other aspect that I would like to discuss with both Francesco and Stefano is the fact that because we are investigating what is the intelligence of the system, clearly there is some kind of fight between the cloud and the edge. What is your take observing the market? So observing, let's say, people that are buying AWS, people that are buying component in the semiconductor industry. Where you think the industry is bringing this intelligence? What we should expect?
Okay. For sure, there is a push to have the intelligence at the edge. I think this is what we're seeing. There is millions, billions of connected devices. The definition of robot is becoming very blurred. I mean, if we want to make a very, crazy, comparison, in Star Wars you have C-3PO, that is the protocol droid. We don't really need a protocol droid. We just need our AirPods to do the translation time, right? So real time. So that's basically your translation robot. You don't need to carry it around. It comes with you. So robot definition is changing and is really pervasive in every, in everything that we see. And this really requires a deployment of the capability of processing at the edge. Of course, there is a cloud. Okay, it's like us in our society. I mean, everybody works as an individual, but then we meet at the bar in Italy, especially, to play cards. And we discuss what happened in the morning, and that's what the cloud comes as a cohesive in the society, and then brings improvement. So there is a need to have independent operation, edge AI. Your thermostat needs to be able to decide by itself. It cannot just go back to the cloud. Your Roomba has to do it by yourself without you being around. It cannot wait, and it needs to take decisions. So that's to me the real challenge, and what we're seeing from our customer, from the industry, how to deploy, decision at a local level. And then, of course, bring back the knowledge to a cloud for deployment and keep improving on that. Okay, but there needs to be for sure a push to have local decision. This is what we see.
Yeah, I think in my view, there's been a perception that it's the cloud or the edge, right? And I think it's wrong. It's really an hybrid model, and I think that we believe in that deeply because even 3-4 years ago, we actually launched a capability that is completely at the edge. It's an AWS IoT service that is actually completely at the edge, exactly because we knew, again, to me, I lead IoT, there is no IoT if there is no edge, right? You need the edge, right? It can't just be the cloud. So it's an hybrid environment where you really look into what are the right workloads. What do you need to do at the edge? What do you need to do in the cloud, right? Where do you train the model? Where do you do the inference? Where do you deploy and orchestrate the models? What we see today is actually, it's exactly, there's certainly a lot of inference running at the edge because that's where it should be. Sometimes it could be because of data privacy, data sovereignty, that needs to remain there at the edge. It could be just time sensitive, and you need to take the action immediately, right? If I'm driving my electric car, it needs to tell me immediately that I'm falling asleep. It's not going to send the data to the cloud, figure out is he falling asleep or not. Now, where do I train the model, right? Where do I resend more data to optimize the model? How do I then OTA the model back to the vehicle, to the robot? A lot of these things are going to be done in the cloud. So it's a coexistence. It is definitely not one versus the other.
Okay, I would like to say thank you because, of course, the question was built exactly to give you the opportunity to share exactly this content. It makes no sense to talk about an architecture as like a place with barrier, frontiers, and specific subdivision. And the fact that you highlight how hybrid is now the way in which we should design software, hardware, and service and solution is fundamental for our startup because sometimes just because it's easier, just because the team is not big enough, sometimes because initially the cost is not a big issue, we take the easy way. But scaling requires that the architecture is, let's say, proficient in the beginning. It is solving the actual problem since the beginning. It's trustful since the beginning. And thank you for using the word coexistence, because this is exactly where I would like to land with the next question. I would like to start from you in this case, because again, we are seeing all those robots of any kind, any size, any shape, including, again, translation with a bubblefish. And all those things are entering in our life in a, let's say, very visible way. So you are in the position to talk continuously with people that are probably very positive in receiving this innovation, interacting with this kind of new machines coming to us. And we live in San Francisco, and Waymo around, it's completely well accepted. And I see tourists coming to San Francisco and look at the Waymo, not at the cable car or things like that. However, do you see any other side? Have you received any comment or insight or anything that might help us to think how well received this coexistence could be in the near future?
Obviously, these are machines that can weigh, upwards of 200 pounds. They can be dangerous. They look dangerous sometimes. They are supposed to do dangerous tasks, repetitive, boring, whether it's at the factory or the warehouse or whatever the case may be. Safety is is the most important thing. And so I've been fortunate enough to work on a small piece of the US safety standards for the humanoids led by ASMC, I think, Aaron Prother's organization. And so there has to be some sort of guideline for when a humanoid can coexist and operate safely next to a human or next to a group of humans, whether it's at the at home or at the factory floor or in an entertainment environment or whatever the case may be. There has to be safety guidelines, and we can't wait just for OSHA to come in and impose the actual guidelines that have been imposed on factory floors and warehouses for the home, for the retail stores, for the entertainment. So that's really like standard. Safety has to be there before any coexistence has to happen. And then that's on like the infrastructure side or the policy side even. On the technology side, obviously we're making a lot of progress, but we're still a few years away. The form factor has to be less intimidating. It has to be somewhat inviting for collaboration. We've all seen, I think, lately, NEO having introduced their, or 1X having introduced Neo, their humanoid, for $20,000, $500 a month as a lease, and they plan to ship in 2026, end of 26 and early 27. I think it's going to take a lot longer because there will be a regulation, and so we don't want to wait until there is an accident before regulation steps in. That's part of my work, not only on the education side, but also on the framework side, on the policy side, educating the consumers and whatnot. Waymo didn't get here just without any incidents, without any regulation push. There has to be, obviously, both a push and a pull. The technology will get there no matter what, and that will eventually push the envelope. But I truly believe that we're still a few years away from coexistence because what's at stake is the human life, and the most valuable thing I think on Earth is the human life.
Thank you. So, Peter, we just heard that we are not yet there. And in terms of the velocity of propagation of any kind of technology, the cultural acceptability is absolutely core. My question for you is, what do you see in this direction of the coexistence, and what your researchers are inventing this moment? Are things that might help in the direction of coexistence, or are, I don't know, radical, destructive kind of super monster? I have no idea what you're working on, guys.
Yeah, this is a really important topic. So, and which is why I went back to describing that there's so many different types of robots, because part of it is going to be educating the public, educating regulators, educating other technologists about sort of where the hazards are. The hazards aren't just physical. There's hazards in, as we know, hallucinations in LLMs, right? So there's lots of different places where hazards and risk can get introduced. One of the things we're working on is, in many of these foundation models, we don't really know what's going on. So how do you create explainability, right? So that you can understand how decisions and actions were made and manage those. Certainly if you want to talk about physical coexistence, there's lots of different technologies in terms of sensors that could be applied to robotics. I think it's going to be some time before you really see sort of human and robot coexistence, cooperation, whether it's in a factory, maybe something on a battlefield. There's probably a little less restrictions. But I think in the typical place, you're going to see some restrictions. Most robots are still sort of behind a cage. And in many cases, they will probably continue to be. If you've been to an Amazon warehouse, right, there's a robot section and there's a human section. There's not necessarily, they don't really overlap all that much. And for some time, there'll be some interaction. Most of that interaction is going to be very controlled, right? So, we used to say cobots just meant slow, right? And so there are ways to mitigate it. I wouldn't wait on trying to make sure that I can operate next to a humanoid. I'd want to look for all those other opportunities to introduce physical intelligence into objects in our environment.
Leandro, let me add one thing, because there's certainly the safety element, which I agree, but I think one thing that we are certainly looking into, there is the robots, and then there is, AI agents. I mean, we are certainly looking into, from a leadership perspective, what's going to mean for you to have 50 engineers, 50 agents, maybe 50 robots. To me, that's the coexistence. Also, as leaders, how are we going to manage this sort of hybrid workforce? That's a big topic that we are certainly looking into, because it's not too futuristic. It's coming up. Maybe the robots will take a little bit more time, but the agents are there. They are agents. They are certainly today complementing real workforce, right? And that coexistence and understanding the task and how you handle them versus real people, it's something that we need to really consider.
Absolutely, and thank you for, let's say, intervening, because it makes the conversation much more dynamic, and I recommend to everybody to start to interact also, because in a couple of minutes, let's say less than 5 minutes, we want to open for a couple of questions to the audience. So it's the moment in which we as a panelist should ignite the conversation with the entire room. And in this sense, I would like to underline how sometimes working with startups, so you see again the glimpse of some potential future. I was asking to Peter about what the researchers were doing, for example, in terms of coexistence, safety, because we see every day robotic hands, sensors, electromagnetic fields around bodies that might help the coexistence of robots that in theory in the future should live in our house. On the other hand, those Italian companies and startups, they do not pretend to design and bring to the market the entire robot. They have just some piece of the technology. And I feel that this is also part of the business conversation that starting from those startups might become a conversation also here in Silicon Valley. Again, because we are going to be again an hardware Silicon Valley, again being able to manufacture locally. And this means that you do not have just a silos company that do everything inside. That they, of course, start from semiconductor, put together all the solution available on the cloud and on the edge, and take advantage from all the research that is available to create those very sophisticated new generation of robots. And having said that, looking at the clock, I would like to give you the opportunity to address those companies, our startup, the companies that are creating those spare technology with your advice and wisdom from the position in which you are. Madar, you want to start?
Absolutely. I look at startups almost on a regular daily basis. There's a large group of startups that come to us, whether they're funded, not funded, at the inception stage, at a lab, or whatnot. And there's one common thing that I generally say to everyone: just pick up a trend, and we can all agree now that it's AI. And pick up like a secondary trend, so potentially now it's physical AI, which is the reason why we're all in here in this room. And then look at all the gaps in the markets that have not been fulfilled. So do your market research, check out everybody that's either working on a foundation model or a world model or a simulation engine or a humanoid for the supermarkets or the convenience store, or whatever the case may be. Try to identify some of these gaps, see if there's enough passion that you have. Work with the existing tools. The AI is open for everyone to use, not just in the US or in Italy or in China, everywhere. Pick up the existing tools, build with them for something where you can see a major gap. And there will always be a gap, whether in this generation of startups, whether in this generation of physical AI or the next one. Every single month and every single year, there will be gaps, because that's how innovation progresses. And that's my 2 cents.
Thank you. Peter, you want to follow up and maybe helping those startups to understand that they do not have to invent everything at home, and maybe there are facilities and researchers and studies that might help them to speed up the process, also to accelerate on the path. Velocity is fundamental.
Sure. First, I want to build off Mono's comment, which is find a problem to solve, right? So those are the gaps, right? Find a problem to solve. There's lots of hype. There's lots of different things people are doing. It's the ones that are solving problems that go from technologies to businesses. So that's the first comment. Second is, if you're looking for technology to solve a problem, there's lots of sources. There's academic sources. There's research institutions like ours. There's other technology companies. I think one of the benefits of being in a place like Silicon Valley is reaching out across to, I think you said something about being competitors and collaborators. That's a very good skill to have. If you can find those other groups that are trying to solve similar problems, and you can each sort of have a portion of that solution, there's benefits to collaboration, not just competing.
And
Call me if you need help.
And I love the answer, because again, observing to this flow of startups, 300-400 startups that we saw coming from Italy, again, sometimes there is this kind of inventor syndrome in which you feel alone and watch at the desk and try to solve all the problems, and sometimes you reinvent the wheel or just go in the wrong direction. In this sense, with building the cloud, with building the semiconductor can facilitate a lot. So if you want to share your advice to those startups, and maybe if you have something in terms of, I don't know, service, SDK, or something that they might assess, that could be a good moment to share it.
Yeah, thank you for that. So, without doing advertisement for ST, but we were talking about how many billions of devices are connected. And again, the key I think is the devices are connected. So the physical AI is true. So we have the hardware and the cloud, and they all work together. And if we look at the physical AI, there is what physical AI can do for us, but we should also look at what we can do with physical AI, but also what physical AI can do for us. So take a different approach instead of pushing, our solution. Also listen to what's around us. And from a ST point of view, again, as I was saying, to facilitate, startups or innovation, we have all the foundation blocks other than the big CPU. So we have the sensing, we have the actuation, we have the security, and we have the processing and the communication. And what we also have is that we have over 200 partners on top of our own system. We have 200 partners around the world that are enabling solutions based on our systems. So you can get design kits, for example, and start from there, and different software, hardware to enable rapid scalability. And the other thing with ST is that you have connection. You have connection to ST, but you have connection to our partners, to our customers, and sometimes also to our competitors, because I think, again, this is really something that is a revolution, or actually an evolution of the society as a whole, not just one company doing something specific. Okay.
Stefano?
One of the things that we have at Amazon, and it's public, we have specific leadership principles that we really live by, on a daily basis. And we have about 14, 15 exactly. There are a few that really stick to me that always I try to advise people to follow. The first one is customer obsession. Just going back to really understand the customer and really be obsessed by the problem that you're trying to solve or the opportunity you're trying to build. So be draconian on that, really be obsessed. And the second one, kind of, again, going back to the advices which we have, which is be curious and learn, experiment, try, reiterate. You might fail, that's okay. I've been there now 5 years. There's many projects that we have started and we failed, but we have learned from them and we kept going. So my advice is just, don't be afraid. Again, iterate, fail, restart. Most of the big successes that we had at this sort of process. And particularly for the startup community, we have a lot of programs. If anybody needs support, help in any sort of shape or form, just reach out.
Thank you. So I would like to say thank you to the panelists. First of all, with a round of applause. And we will take just one question from the audience. Acadina has a microphone. 2 questions. Okay, the director say 2. 2 questions from the audience. Who offer more?
Okay, there's one over there.
Okay.
2 over there.
Okay, can you provide the mic, please? So, introduce yourself, please.
Hi, thank you all. So my name is Santiago. I'm CTO of a company called Robots for Humanity. We train humanoid robots to deploy in industries. So right now we address the gap of manufacturers and industries. So we don't build the robots, we just train them for our customer needs. And I was wondering, what's your take on that gap, on the actual training of the models? With advancement in AI, how long do you think that gap will be there? When AI will be as smart as it can actually see a task and learn it from itself?
I think it depends on the complexity of the task, but we're actually there. Foundation models are created for this specific task. It's for them to be, to generalize as much as possible. Remember, we're still, what we call AI is still somewhat supervised learning, which requires annotated data or some sort of human data. We're not in the unsupervised model or AI yet, which is the reason why some of the world models are kind of, it's a research topic still. But short answer, depending on the complexity of the task, it could literally be a few minutes if you use imitation learning for a grab and drop or whatever the task may be, or it could be a few months. And I think the second caveat is it all depends on where and how you train. If you have a friend at AWS, you might train just faster.
The other thing is that it looks like, AI is eager to learn itself. When you talk to ChatGPT and you ask a question, then ChatGPT at the end, they ask you a question, to
Self-learning.
keep learning. So like, dude, okay, whatever. So it makes them think and try to learn as fast as possible. Of course, supervised, but that's the thing.
Yeah, so one of the things specific to your question that we're seeing is in the vein of complexity, is think of it as sort of concatenated tasks or tasks after. So we're seeing the first task, it's done today, you can do it. But then it's got to go move that to the next task with the context of the previous task. We're pretty close. Most of the time it's right. That third or fourth one, it's starting to hallucinate and gets really weird. But that's just a matter of time, right? And then as you get multi-agent sort of systems, it's that transition between the agents, but we're not that far away.
Thank you. Thank you.
Anything to add? No? Okay, it's fine. Second question. Where is the second question? Oh, welcome.
Yeah, so my name is Frederick Sev from the CLAT. My question is about the bottleneck in AI for robotics. Do you see the same bottleneck in robotics than in AI factory, meaning the memory wall and the power wall? Is there a strong bottleneck there, like in AI factory?
Battery for sure, if you want to have continuous battery. There's a recent report that came out of McKinsey in October. They basically disclose 4 problems that humanoids have today, and one of them is battery. You want to have continuous battery, you want to have fast charging, and you want to have humanoids that can actually replace their own battery. That's one topic you mentioned. Power, I think it's probably related to battery, but that's one bottleneck. The major bottleneck is safety. It's really safety, depending on where the deployment is, but if it's anywhere near humans, it's safety. And if it's not near humans, that means it's actually doing something that's somewhat narrow, single-tasked, narrow-tasked, which is similar to what agility robotics basically is doing in the warehouse, picking up bins, dropping them off, or whatever I think Figure is trying to do also with some automotive manufacturers. But that's still quite narrow, so it's not generalizable. That's also a bottleneck, in my opinion.
Okay, so thank you again for the panelists.
Thanks.